Hello everyone, this is Boris Baeta with the Oaks Technology Center. This is a short intro class for IP addressing. Um, my aim is to show how our classes are offered here at the Oaks Technology Center online and to give you a little hint as to some of the topics that we'll be covering. So our agenda for today, we're going to go over IP addressing really quickly. We're going to understand classful addressing and why it's important. And then we will find out the why behind the what. Many classes will show you what addresses are supposed to look like or what the addresses are supposed to do, but not really why. And we'll see some of that in a moment here. Okay, first let's just start with our overview. So IP addresses, they're 32-bit addresses. Okay. Now, the internet, despite what Al Gore says, was actually developed by the U.S. military. It was for communications in case of a nuclear war or in case of any sort of war here in the United States, where the traditional communications infrastructure would have broken down. Okay, so here's the address format. So the first shows the dotted decimal format that we're all familiar with. So in our case, 10.100.33.14. So this is human readable, but if the machine sees this address, it does not see the dots or these numbers. It will see these 32 bits, this 32-bit string of characters that represents this address. And we'll learn how to translate from these numbers to this number and vice versa. Okay. Finally, we have the address classes. Okay, so we're going to cover the first 3 of the 5 address classes in our short tutorial here. Class A, really large networks. Companies like AT&T, schools like MIT, and the U.S. Army all received Class A networks. There aren't very many of them, so they've actually all been given away. You cannot purchase a Class A address anymore. Class B addresses, those are a little more common, but once again, they're for larger companies. And then finally, Class C networks. This would be the type of network that you have in your home. If you have a router from Linksys or Cisco or D-Link, the network address that you're going to receive from that router will be one of these Class C networks. Okay, and let's continue with IP addressing. Okay, so Class A addresses. So this shows the range of Class A addresses, the total possibilities. So from 0.0.0.0 to 127.255.255.255. In our dotted decimal configuration here, the maximum number that you can have is 255 in any one octet. But you'll notice here in Class A, the first octet is limited to 127. So if you have an address with the first octet between 0 and 127, it is a Class A network, or one of those very large networks. In our case here, we have 4.23.14.16. We notice immediately, we see a 4 at the beginning, we know this is a Class A network. Okay, Class B networks, very similar. The first octet only transitions between 128 to 191. So the last 3 octets can go from 0 to 255, but that first octet has to be between 128 and 191. So if we see an address with the first octet between those 2 ranges, or between that range, then it is a Class B network. And then finally we have Class C networks. Okay. Class C networks, it's exactly the same as Class A and B, except the first octet, the range is between 192 and 223. So a very common address that you'll see, 192.168.1.15 or 35 or what have you, or you may see 192.168.0. whatever. These are both Class C networks. So in our case, we Our example is 220.15.33.44. Those last three octets could be any number, but for a Class C network, that first network has to be 220. And actually, once again, when I say any number between 0 and 255 for those last three octets. But the first octet has to be between 192 and 223. Okay, class, now we're on to the what and why. And in order to proceed, we're going to have to do a little bit of binary math. Earlier in the class here, I used the term octet, and we're going to see why we use that term. Now, we see we had a 32-bit number divided by 4. Obviously, 32 divided by 4 is 8. So each of those numbers in the before and after the dots in our IP addresses are made up of 8 binary digits. Our binary digits can only be 1 or 0. So here, let's see how we go from a decimal number or human readable number to a computer readable number, which is a binary number. So we start out with a binary chart, binary to decimal chart. It starts at 1 at the right and doubles until it gets to 128. And if you notice, we have 8 possibilities. So it's really easy to go from binary to decimal. So at each position, if we have a 0 under the bit position, it shows 0. In our case, we have all zeros. But if we have a 1 under the bit position, then that number is a part of the decimal number that we're creating. So in our case here, we have 0 under 128, 0 under 64, 0 under 32, 0 under 16. We have a 1 under the 8, a 0 under the 4, a 1 under the 2, and a 0 under the 1. So if we add 8 and 2, we have the number 10. So the number 10 in binary is 0, 0, 0, 0, 1, 0, 1, 0. Hope I don't have too many zeros in there. Let's do one more. In our case here, we have the binary number 0, 0, 1, 0, 1, 0, 0, 0. By using our handy dandy chart, we can see that that binary number translates to a decimal number of 40. Let's do one more. Here we have 1, 1, 0, 0, 0, 0, 0, 0. If we add 128 and 64, we get the number 192. Now you know how to translate from binary numbers to decimal numbers. So now, remember with our Class A addresses, we had the limitation of the first octet going from 0 to 127. And by definition, a Class A, the high order bit or the leftmost bit has to be 0. So in our case, we use our binary to decimal chart one more time, and we see what would happen if we had all zeros. And what's most important is this leftmost bit, the highest order bit, has to be 0. But what happens if we turn on all the other bits, if we have ones in all of the other positions? Now we have to have 0 in this first position, but the other bits can be 1 or 0. In our case, this is all ones. So the lowest possibility is all zeros, which is 0, and the highest possibility is 127, because this has to be 0. And if you add up all of these other numbers, you come up to 127. Class B. By definition, Class B address have to have the high order bits to be 1 and 0. So here's our chart one more time. And here we show the first 2 bits as 1 and 0, and all the rest is 0. That gives us 128. So this is the lowest possible number. And if we have the 1 and 0 bits as they are by definition, and have all of the other bits with 1s under them, we have the highest possible number, 191. Okay, class, and finally we have Class C addresses. Now we remember from the beginning, we had the first octet going from 192 to 223. Well, by definition, the high order bits have to be 110 in order for an address to be a Class C address. Let's see why. Okay, so we have our chart once again, and here we have the first 3 bits as 110, which gives us this number, 192. And then the highest possible number that we can have with 110 in these first 3 bit positions is 223. So the lowest possible number is 192. The highest possible number is 223. Finally, we have Class D and E addresses. We are not covering that in this course, but in some of our other courses, we have a CCNA course and a subnetting class. You can find out more about our other upcoming classes on the www.oakcenter.com website. We hope to hear from you soon. Thanks for spending time with us.